let T be the set of all triangles in the Euclidean plane, and let relation R on T be defined as A is related to B if A is congruent to B for all A comma B belongs to T. That is the set of all triangles in Euclidean plane. Then R is, we have given the T is the set of all triangles in the Euclidean plane, and a relation R on T be defined as A related to B. If A is congruent to B, then for all A comma B belongs to T. So A is related to B if A is congruent to B for all A comma B belongs to capital T. Now let's check whether this relation is reflexive, symmetric, or transitive. The very first case, that is reflexive. In a reflexive relation, A must be related to A. It means that A is congruent to A. That is, A is congruent to A. So we know that the any triangle is congruent to itself. So this relation is a reflexive relation. If you talk about symmetric relation, in a symmetric relation, if A is related to B, then there must be B related to A. It means that if A is congruent to B, then B must be congruent to A. So meaning is same. If A triangle A is congruent to triangle B, then triangle B must be congruent to A only. Okay. So both are same thing. So the relation, the given relation is symmetric as well. Let's talk about third point, that is transitive. So in a transitive relation, if A is related to B and B is related to A, then A must be related to C. So we can see A is congruent. So relation is A is congruent to B, not B, it is congruent to small b. So and B is congruent to C, not A, congruent to C, then A must be congruent to C. We know that if A is congruent to B and B is congruent to C, means all these are congruent to each other, means A is also congruent to C. So it means that the relation, the given relation is transitive as well. If the given relation is reflexive, symmetric, and transitive, then we can say that the relation is equivalence relation. So option C is correct. If the given relation is reflexive, symmetric, and transitive as well, then the relation will be equivalence relation.